We will start with the chapter 10, straight lines. Now see, this is your continuation of coordinate geometry that you have did in your previous classes, right? So we will recall some concepts that we have already learned in previous classes, and then we will uh, carry forward that concepts uh, to some more advanced level, right? So I think you might be knowing that this is your Cartesian coordinate system where two perpendicular lines intersect each other at origin, right? Uh, the horizontal line is called x-axis, whereas the vertical line is called as y-axis, and this two mutually perpendicular line divides this whole plane in four quadrants, where this is your first quadrant, this is your second quadrant, this is your third quadrant, and this is your fourth quadrant, right? Uh, the part right to the origin is called as positive x-axis, whereas the line or the part to the left is called negative x-axis, right? Here we take the positive values of x coordinates, and here we will take the negative values of y coordinate. Here we will take positive values of uh, y coordinate. Here we will take negative values of x coordinate. Sorry. Here positive values of y coordinate. Here negative values. So above is the positive values, and below x-axis is your negative value. So you can see that first quadrant is attached to x coordinate positive and y coordinate also positive. So if your coordinates have positive sign, both of them is having positive sign, that is x coordinate is also positive and y coordinate is also positive, then your point will lie on in first quadrant. Whereas if your x coordinate is negative and your y coordinate is positive, then it will lie in second quadrant. If both of them is negative, then it will uh, lie in third quadrant. Whereas if x is positive and y is negative, then it will lie in fourth quadrant. So this is how we plot our point. Now, after that was the concept of distance between the 2 points, right? So suppose if I plot 2 points, say x1, y1, and point x2, y2, then the distance between these 2 points can be found out using the formula. Distance formula d is square root x1 minus x2 whole square plus y1 minus y2 whole square. You can take it either way also, as y2 minus y1 whole square plus x2 minus x1 whole square. Then we have uh, seen that section formula, where we can find the coordinate of a point that divides the line segment AB, whose coordinates are x1, y1, and x2, y2. And if we are interested in finding the coordinates of point P, x comma y, then this point P, x comma y can be found out using the formula If we know the ratio of division, that is, if this point divides this line segment in ratio m is to n, then the formula will be mx2 plus mx1 upon m plus n, uh, my2 plus ny1 upon m plus n. This is your section formula. After that, we will move on to the midpoint theorem or midpoint formula, which is a special case of your section formula. If you take this point exactly in the middle of line segment AB, then the ratio of division will become 1 is to 1. And in that case, if you will keep the value of m and n as 1, then you will have your midpoint formula. So I will just rub this. So your midpoint formula is Px comma y is x1 plus x2 by 2, y1 plus y2 by. This is your midpoint theorem or midpoint formula. And last was the area of triangle. If your vertex A is having coordinate x1, y1, if vertex B has coordinates x2, y2, and C coordinate have vertex C have coordinate x3, y3, then the area of this triangle can be found out using formula. Area of triangle ABC is half mod x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. This is your formula of finding the area of triangle if you are given with the coordinates of the three vertices. Now see, we will move on to the more advanced or further concepts, that is the slope of a line. See, we will try to understand that what is the slope of a line. See, if your line is horizontal, then the slope of this line will be 0. As you can see that if I uh, keep a marble on this line, then it will not roll over in left or in right direction, because this is your balanced floor. You can consider this as a floor of your room. You will observe that the ball kept on the floor will not roll anywhere, because the floor is leveled, right? So that if your line is horizontal, then the slope of that line will be 0. But if you draw a line which makes some angle with the horizontal line, if it is making an angle with your horizontal line, as you can see that here your line L is making some angle with your horizontal line M. Let's say the angle made is theta, then this line is inclined to line M, and then this line will have some slope, right? And if you are interested in finding the slope of a line, then the formula for that is tan theta. But this theta should be considered as the angle made by the line with the positive direction of x-axis. Be careful. See, if I want to see, then this line will make this angle with horizontal also, but this angle will be considered as the angle made by this line in the negative direction of x-axis. But here particularly we will take that angle that is made by that line with the positive direction of x-axis only, and not the negative direction of x-axis, right? So this is how you find the slope of a line. Now, the interesting fact is, if we will see that if I go on increasing the inclination of this line, as if I make this exactly parallel to the y-axis, then if I am interested in finding the slope of line, this time this line is making and right angle with the horizontal line. So if I keep that as pi by 2, then I know that it is undefined slope. So always remember that the slope of vertical line is always undefined, whereas the slope of horizontal line is always 0, right? If I still increase my inclination, then you will see that the angle made by this line with the positive direction of x-axis is more than 90. That is, the angle is obtuse, and if I consider obtuse angle, then that angle will go in second quadrant, and you know that the second quadrant will have the values of 10 negative. So in that case, the value of the slope will be negative. So you can easily consider the inclination, or you can easily detect the orientation of the line with respect to x-axis. Means if you have the value of slope as positive, then it will make some acute angle with the positive direction of x-axis, whereas if the value of slope is negative, then definitely that line will make some angle which is obtuse with the positive direction of x-axis. So you can easily just interpret the orientation of any line with the positive direction of x-axis if you are just knowing the value of the slope of a line, right? This is your first formula, or one of the formula to find the slope of a line. If you are having the angle made by that line with the positive direction of x-axis, but sometimes we may encounter some cases where the angle made by the line with the positive direction of x-axis is not given, then we will consider case 2. Here, this was your case 1, where we are given the angle made by the line with the positive direction of x-axis. In case 2, here we can say that this is 2-point form, that is line passing through 2 points, say x1 y1 and x2 y2. So if you are interested in finding the slope of a line when that line passes through 2 points, then also you can find uh, the slope of a line, but this time the formula for that will be y2 minus y1 upon x2 minus x. Right. This is the slope of a line in the case when the two passing points are even. Right. See, the deep explanation of that is already given in your textbook. But if I tell you that you just learn this, the application of this formula is more important than the derivation of this. But still, if you want, then you just ask me. I will explain this uh, if you wanted. So right now you have seen two formulas of finding the slope of a line. Both of them is having different condition. That is, if the angle of inclination is given, then you will apply the formula tan theta. Whereas if the two passing points are given, then you can apply this formula y2 minus y1 upon x2 minus x1. This will give you the slope of a line.
Yes, sir.
Let's continue our explanation with the condition for parallelism and perpendicularity of two lines in terms of the slope. So here we will try to derive the condition for the two lines to be parallel. See what will be the conditions of the slope if the two lines are parallel, and what will be the condition for the slopes if your two lines are perpendicular. We will try to find the solution for that. Let's say I have two parallel lines, line L and M, having slope m1 and m2. Now let's say this line makes an angle theta with the positive direction of x-axis. Then as these two lines are parallel lines, this angle will also be theta only, according to the concept of corresponding pairs of angle, where your x-axis will be your transversal, and these two angles will be corresponding pairs of angle. And you know that corresponding pairs of angle are always equal in, in the case if the two lines are parallel. So if I want to find the slope of line M, then it will be tan theta, which is m2. And if I am interested in finding the slope of line L, then it will also be tan theta, which is m1. So here you can see that the slope of line uh, L is equal to slope of line M. So this is the condition for the two lines to be parallel. So if two lines are parallel, then their slope will be equal. Condition for the, so here it will not be a conditions but just a condition. Only single condition is that condition for the two lines to be perpendicular. So if two lines are there and they are perpendicular to each other, means they are intersecting each other at right angle. Let's say the given line is ML, and the slope corresponding to that is M1 and M2, right? So the condition for the two lines to be perpendicular is the product of their slope should be equal to minus 1. M1 multiplied by M2 should be equal to minus 1. So if you multiply the slope of two lines and you get the product of that as minus 1, means it is proved that two lines are perpendicular to each other. And if it is given that the two lines are perpendicular to each other, then you will take the product of their slopes as -1. So this is the condition for the two lines to be perpendicular.